In today's video, we'll be going over this puzzle piece that is perfect for 3D printing. So we'll be going over, how to create a tolerance, how to create some of these connection pieces, and all of those steps that creates this design. So let's go ahead and jump right in. For the puzzle piece, we're going to start with a rectangle. The first thing we're going to do is, let's go here into Grasshopper mode. I'll double click here and go to a rectangle component. And let's plug in a slider for the X and Y. And this has to be a rectangle. Now, there are other steps that we can take for it not to be a perfect square. But for now, let's just give it one value for the X and Y. So I'm plugging in 50. Next thing is we want to get the midpoint here. So I'll take this and I'll go here to explode. This will explode that rectangle into 4 different lines. Now we can get the midpoint of this. So the middle of that segment. And we want to pick just one of these. Now it could be this one down here or this one up here. Now I do like to use the one up here because then the values that we'll use are mostly going to be positive or positive Y. So let's go to midpoint here and go to list item. And let's check 4 of these. We're just going to use number 2. Let's go here to curve or to point. And I'll disable the preview and all of this stuff here. Now we can focus using this point as the point for our connection piece. For the connection piece, we need to, there are many ways that we can create the connection piece, but the one that I like to do is this kind of L shape or like a T shape. So let's take this point and move it. So we'll start here by moving it in the positive X and negative X. So we'll move this in the X direction and I'll bring in a value 5.5. And we'll do the same thing going the other way. So I'll copy this and bring in a negative value. So we have 2 points. Next thing is we're going to take these 2 points and we're going to move them up in the positive Y. So let's do that. Let's take these 2, plug them into here, and we'll just do this. We'll bring in a unit Y. We'll copy this slider. And I'm going fairly quickly here. I just want to be efficient with the time and show you the steps here more than anything. So let's move these in the positive and negative Y. Or actually both positive. Right? We want to move them both of these up. Next thing is now we're going to move it positive X and negative X. So we'll copy this again. And I'll copy these 2 and do that to this one and this one. Actually, it's going to be these 2. Next thing is we're going to move them up again in the unit Y. So we'll take these, copy them, and plug both of these. And we can either use that value or a different value. So I'll copy the unit Y. So technically now we can connect all the points, right, by using a polyline. So you can either, yeah, let's just plug in one at a time. Sometimes I do like to put them into a point component and do it this way. So we'll organize them. So we'll start with this one, then continue with this one, and we'll work our way around. So it'll be this next one and the last one. And then the last one, which is this one. And then we'll start with this one and work our way back. So holding down Shift, I'm adding additional inputs. And now I know that I need this one. And lastly, this one. Let's plug in those polylines or the points into the vertices for the polyline. And now we can turn this into, we can close this, right? So we can take the last, or we can go here to closed, set Boolean to true. Awesome. So now let's go here, boundary surface. And we can also do a fillet or round off the edges here and then close it. This way the connection could have this rounded off, but let's keep it simple for this exercise and I'll show you the next steps. We can always come back and further add more details to this. All right, great. So now that we have this surface, let's create a surface also on this rectangle. So I'll go here to surface or boundary surface. And we know that we have, well, let's play around with some of these things so you can see that everything is still working. That's based off of the midpoint. That's always going to work in that sense. Then we have how wide it is as the connection. So the thinner it is, it's actually going to be weaker. The wider it is, it's going to be a better connection, but you don't want it to be so wide because it defeats the purpose. So let's change the extension here. This is the same thing. The longer you make it, the weaker it'll be. So that's something else to keep in mind. And that's if you're 3D printing or fabricating some of these pieces. This is going to be the extension the other way. And here, the overall extension. Great. Now, the next step is one that I do every time that I need to rotate something relative to a center point. So we know that we need to take this and rotate it 4 times here. So we need to get the midpoint and rotate it 4 times. So this is how I do it. I go to area to get the midpoint of the surface, rotate to rotate the piece, and make sure that it has degrees, and then series to create a series of rotations. Since we're using 4, and it's only going to be 4 because we're using a square, this is where I use quotation marks, 360 for 360 degrees. And I do have my panels colored in white here, and then I changed that to be my default color. So that's if you're wondering why it looks like that. So 360 divided by the number of copies you want. So quotation marks 4. 360 divided by 4, that's going to give us the angle rotation that we need. 90. And how many times? 4 times. So we'll plug in the 4 into the count, the result into the step, and the series into the angle. Now we can rotate this relative to. So right now it's doing it relative to the center point. This is why we need the centroid. There are other ways to get the center point. We can evaluate surface, but this will give us a perfect the result that we actually want. So now let's take this and separate them. So let's take this stuff, disable preview. Now we need to go to item or list item. And with list item, we're going to bring in these four. So by adding a plus sign here, we'll be able to add more outputs. So 1, 2, 3, and 4. And now we can go here to a brep, or you can even do surface and have these be separate. Because now we're going to, well, technically there's two opposite of these that we can technically put into the same one. So we can technically do this, but two of these need to be rotated at 180 degrees. So let's do that. Let's get the point on this one. We need to get the midpoint over there. So we also need to rotate this point. So what I'll do is take this rotation and copy it down and plug in this initial point. What that will do, let's preview here, is it will rotate that point around. And now we can copy this down here. And we can separate each one of these points. So we can use the first point with this one and rotate using this first point. It's going to be in the plane, degrees, angle, we're going to plug in 90 or 180 because we're trying to turn it around all the way around. And now we'll plug in the first one. So that worked. Now I'll copy this down here. And this one is 2. So we'll plug this one here, and then 2 goes into the plane. So now we can take this one and disable preview and disable the preview on all of this other stuff. Now it might actually be better if we do it the opposite, but either way, this kind of gets to the point where the reason why is because you don't want to get rid of all the points if you don't have to. But either way, we have these two that we can now put into one. So plug both of those into one. We'll flatten the input. And the last thing we'll do, so that's going to create the form, is going to be region difference. So these are going to be subtracted, so B, and this is what we want to subtract from. And now we'll do union. So region union, we can plug in these and these. So whatever was left over plus these B-reps, and we'll flatten the input. And now we can type in boundary surfaces for the leftover. So now let's move this around. Let's play around with some of this stuff. And the other thing is we can technically move the point of where this is because we have it off of the midpoint, but we can also take the segments and do like point on curve. So if we do point on curve. Trying to think if we can also move this around, so this is also kind of a cool thing. So let's leave it here like at 0.5-ish, or you can technically just do midpoint. And let's move some of these things around. When you move it in the X direction, it does more than in the Y direction. And the reason why is because it does it twice as much, since we're doing it both positive and negative. So with that being said, let's take this and do a fillet. And we'll fillet the results here and plug in the surface afterwards. So the radius, we'll do 1.500. And this is the result here. We can play around with the amount. It's just good to know that we could do this too. So, all right. Last thing, for this to interlock with another piece, if you're trying to fabricate this or 3D print it, you can't just cut two pieces of the same. They will not fit unless you sand it down or do some kind of post-processing. So what we're going to do now is take this and we're going to move it the same amount. Let's do this. Let's move this the same amount in the X direction. So the same amount that we have the size here, 76. This is going to be the size of, or the amount that we're going to move it. The issue is we need to rotate it. It's not an issue. Just have to bring in two more components. So area, and then rotate. Now, the cool thing is, since we're only doing it once, you could just plug it in using area here into the plane. So plane is where it's going to rotate from, and then geometry here. So you can just disable the preview on this one, and technically it's now interlocking perfectly. So this is the reason why I love parametric design, is all of this stuff is just, if you program it correctly, you can have some of these things just working flawlessly, and it's so amazing to fabricate them. I 3D printed a few things, and it's really cool to play around with tolerances and trying to figure out exactly what the best numbers are for your setup. So okay, moving along. Now the tolerance. So we're going to have to offset this, and the distance is going to be the tolerance. So I found that 0.25 works for me, 0.2500, and this is for 3D printing. So this is in millimeters. And if this is the wrong way, we can go to negative. So what we technically created here are two puzzle pieces, which means that let's disable the preview here, and let's create a boundary surface on this one. So we've created two pieces. This is the tolerance, 1 millimeter. We'll do 0.25. Now we have puzzle piece A and puzzle piece B. Now puzzle piece A cannot connect with puzzle piece A, and same with B, it cannot connect with itself, but A can connect with B. So this is the cool things that we can do with this. Now, if you have any questions, let me know. I'll have this one for you to download under the YouTube portion. So check that out. And I also have optimized scripts on my website. So if you want to check those out, I also have them there. Thank you for being here. I hope you enjoyed the content. Make sure to subscribe for more. and I hope to see you next time.